Section 2.1, we're looking at conditional statements. Our essential question, what is a conditional statement, true or false? I have several things that we're going to define here. And realize conditional statements is a lot of writing. It always causes issues with math stuff, but there's a lot of writing with conditional statements. So a definition, our conditional statement is a logical statement that has two parts, a hypothesis and the conclusion. Then we have if-then form, a form of conditional statement in which the if part contains the hypothesis and the then part contains the conclusion. So you look down a bit, I'll talk about how we did this in a second, but if it's a bird, then it has feathers. It's a bird is the hypothesis. It has feathers is the conditional. The if and then are not included in that. So example 1, we say all birds have feathers. So we write if it's a bird, then it has feathers. So think of what in the statement here, if when you're writing that out, is what you're starting with. So here you have all birds as one thought, having feathers as a second thought. That's how I'm separating it. So on B, all 90-degree angles are right angles. I start with the 90-degree angle. So if it's a 90-degree angle, and you can change the wording on this. So I'm going to say if an angle is 90 degrees, just for the sake of English, then what do I know about it? It is a right angle. Now, one of the things we do with conditionals is manipulate them and look at what they're saying and what they are. So we have a couple terms here that we use to do that. The first one is negation. Negation is the opposite of the original statement. Normally, this is putting in a not. So like the negation of it's a bird would be it's not a bird. Okay? Sometimes it's taking it out. So if I had it's not a bird, the negation of that would be it is a bird. Then we have 3 different types of statement that we make with our statement. We have our original conditional statement, and then we have 3 things. We have the converse, we have the inverse, and we have the contrapositive. So the converse is formed by switching the hypothesis and the conclusion. Okay. So if we again look at if it's a bird then it has feathers, my converse would be if it has feathers then it's a bird. The inverse is formed by negating both the hypothesis and conclusion. So I would be looking at my original statement, if it's a bird then it has feathers, and I'd be negating that. So if it's not a bird, then it does not have feathers. And again, sometimes you need to change the English for it to make sense there. Okay, we wouldn't say if it's not a bird, then it has not feathers. Okay? So there's a little bit of changing the English there. But the concept is you're negating both. And then the contrapositive is doing both of those things. Okay? So the contrapositive does both the converse and the inverse. So it's formed by writing the converse and then negating both the hypothesis and the conclusion. So for if it's a bird, then it has feathers, we would be saying if it doesn't have feathers, then it's not a bird. All these things exist as statements, whether they're true or not. So if you're asked to write the inverse, you put dots in there, you write the inverse. It doesn't matter if it's true or not. Sometimes you'll be asked to evaluate whether it's true or false, but the inverse still exists, even if it doesn't seem to make sense to us. So example 2, right, is writing the if-then form of the statement, guitar players are musicians, and it says decide whether it's true or false. We're also going to do the converse, inverse, and contrapositive of that. So you have guitar players are musicians. Okay, so our 2 main things here are guitar players and musicians. So I want to separate them with an if-then. Okay. But again, we need to watch our English here. So our statement would be, if you play guitar, then you are a musician. So our converse, we're switching those. Okay. And we're going to then we would say this is, yes, for truth, whether it's true or not. So we would say this is true. If you play the guitar, you are a musician. Okay. The converse, I'm switching them. So if you are a musician, then you play guitar. Okay. So the question would be, when we're looking at whether that's true or not, is, are there musicians who don't play guitars? And most people would agree that there are musicians who don't play guitars. All right. As we look in the next section, we're going to look at counterexamples. All right. And the specific cases you're thinking of with this that are false, those would be counterexamples. Then we have our inverse. So our inverse, we're going back to this original statement and putting in nots. Okay. So again, the wording changes a little bit just so it makes sense. But if you don't play guitar, then you aren't a musician. Okay. This would also be false. And then the contrapositive is doing both of the things we did in the previous one. So if you aren't a musician, then you don't play guitar. And that statement would be true. One of the things to realize is your conditional statement and your contrapositive, they will always have the same truth value. So if this statement is true, this statement is true. If this statement is false, this statement is false. And that is always the case. Then flipping our paper over, right, we have some stuff up here that talks about definitions. So definitions can be written in the if-then form or its converse. Both the conditional and the converse are true for definitions. So the definition for perpendicular lines is shown for our example. So definition of perpendicular line, two lines that intersect to form right angles. So the conditional, if two lines form a right angle, then they are perpendicular lines. The converse, if two lines are perpendicular lines, then they intersect to form right angles. So example 3 is just looking at the perpendicular part, more or less, of this. We're looking at whether these statements are true or false. So this symbol here means perpendicular. So we're saying, is AC perpendicular to BD? That is true. I know that because of the 90 degrees right here. And our definition says if they form a right angle, then they're perpendicular. Angle AED, which is this angle right here, and angle BEC are a linear pair. That's false. They're vertical angles, so they're not a linear pair. Linear pair would be AED and AEB. And then EA and EB are opposite rays. So EA goes here, EB goes that way. They have the same starting point, but they don't go in opposite directions, so those are not opposite rays. And then our final definition, the biconditional statement. So when a conditional statement and its converse are both true, you can write a single statement that contains the phrase if and only if. Okay? And a lot of times if and only if is abbreviated as IFF. So you'll see me do that constantly. I basically never write if and only if. You're welcome to do the same. So all our good definitions should be able to be written as a biconditional. Example 4 says write the definition as a biconditional statement. So coplanar points are points that lie in the same plane. So what I'm looking for here are my two things that I could separate. So I have coplanar points and they lie in the same plane. Right? So how I wrote it is points are coplanar if and only if they lie in the same plane. And if we look, that's a true statement. If I say if points are coplanar, then they lie in the same plane. That makes sense. It also makes sense if I say if they lie in the same plane, then points are coplanar. B says an angle with a measure between 90 and 180 is called obtuse. Okay, so the concepts here are the measure between 90 and 180 and the called obtuse. So an angle has a measure between 90 and 180. If and only if it is obtuse. And again, I could write that the other way. I could say an angle is obtuse if and only if it measures between 90 and 180. And that is the end of our conditional statements and section 2.1.